Hi, my name is Shreya and I made a video on buoyancy for the Junior Breakthrough Challenge 2015. So let's start. Why is it that while drawing water from a well, the bucket feels heavier when it is out of the water, or when you try to push an empty bottle into the water, you see that it comes back to the top and you feel an upward push? These two questions can be answered by using the concept of buoyancy, and that is what I'm going to explain now. So what exactly is buoyancy? Buoyancy is simply a force, an upward force that is exerted by the fluid on a submerged object. The fluid could be a liquid or a gas. So it could either be a liquid like mercury or water, or it could be a gas like air. Buoyancy can have two very different effects on an object. Either the object would float, as in the case of this paper clip here, or it could sink, as in the case of this iron nail here. So now we know what exactly is buoyancy. So we will try to understand what is the cause of buoyancy. Now in this picture here, you can see this piece of thermocol which is immersed in water. Now the piece of thermocol, it experiences two forces. One force on top of the thermocol, which is in the downward direction, that is the force of gravity. And the other force is the upward force, which is the buoyant force. And this force acts on the bottom of the thermocol. Now we know that the pressure exerted by a fluid increases with depth. So the top of the thermocol experiences less force downwards as compared to the bottom of the thermocol, which is of course at a greater depth, and experiences a greater force in the upward direction. So here we can see that there is a net force in the upward direction. This net force in the upward direction is the buoyant force. Okay, so we know what buoyancy is and what is its cause. But how can we calculate buoyancy of a particular object? For this, you have the formula: buoyant force equals density of the liquid times acceleration due to gravity times volume of the liquid displaced. This is a fairly simple formula, but you just need to remember two things. The first thing is that the density here is the density of the liquid and not the density of the object. And secondly, the volume is of the liquid displaced, which is not necessarily the volume of the entire object, because an object may be partially immersed in water, and then in that case the buoyant force is not acting on the entire object. It is not acting on the portion of the object which is in the air, which is above the liquid surface. A Greek mathematician and scientist, Archimedes, gave a principle which was named after him, that when an object is immersed in a fluid, the buoyant force is equal to the weight of fluid displaced. So the buoyant force is equal to weight of fluid displaced. Let's try to understand with an example. When an object is immersed in water, it displaces 5 kg of water. How much is the buoyant force acting on the object in newtons? So according to the Archimedes principle, the buoyant force is equal to the weight of liquid displaced. And the weight of the liquid displaced is obviously equal to the mass of the object here, and the times the acceleration due to gravity. So 5 kg times 10 meters per second square, and you get the answer 50 newtons. And weight of liquid displaced is equal to the buoyant force, so the final answer is 50 newtons. So now we've understood what buoyancy is, and now we can answer these two questions. When the bucket is inside the well, the water exerts an upward push, because of which the bucket of water feels lighter. But when the bucket of water is removed from the well, that upward push disappears. though even here we have a buoyant force by the air, but it is negligible as compared to the buoyant force of the water. So that is the reason why the bucket of water feels heavier when it is out of the water. And when you try to push an empty bottle into the water, there is an upward push, that is the buoyant force, which does not allow the bottle to go deep into the um, bowl or container that you have. So that was all about buoyancy. I hope you liked the video. Thank you for watching.